Hi guys, welcome first in tutorial. This is Mike. So today we're going to see some electronics with this new project. So here this is a kit called Snap Circus 203. So it got over 40 electronic parts in it, and as you can see here, we can do over 200 exciting projects. But I think we can do much more than that. So that's just an indication for this. So this kit is pretty funny, it's pretty amazing. We can do tremendous things with it, and today I show you what all table is and how it's being used in electronics. And last thing I want to mention, so this kit is for kids that are 7, 8 and plus. Let's say 8 because my own opinion, I think this kit is a bit for out of our older kit, like 9 or 10. That's my opinion. All right. Alright guys, so when you open it, let me open it for you. This is what you find in it. It comes with all these these different projects in it, with different component parts in it. So we have the board here, so you can put all these electronic components in it. Let me remove it, put it on the side. So here you have push buttons, you have microphones, you have LEDs, you have resistors here, potentiometers, a transistor, you have a speaker here, you have a battery holder here, and you have an IC here. All right. And here you have so-called wires. The so-called wires for, let me show it to you. For this project, but it's not really wires, but yeah, you understand what I'm trying to say. All right, guys. So like I said, we try to see this project. So I show you how all door works, all gate works, and we can go from there. All right. So to get started, we're going to need the switches. We need this switch. We're going to need this switch. So we have a push button here. We can call it a switch. We have a real switch here. Hit that one. We're gonna need the battery holder. Let me put that on the side so you can see. I put that here. We have the battery holder here, and of course we're going to need batteries. We're going to need batteries. We got this. Let me get some wires, cables. We can call it however we want. So we got this. We got this. We need the LED too. And I think that's about it. See if we need anything else. So I just pick it back. So we get started with this. All right. Let me put that aside. All right. Before we get started, let me explain you what a OR gate is and how we can make it work. Okay, so it's like in English, we call it a OR gate. OR, like OR. And usually it comes at a table like this, and tables like this. I explain you all of that, guys. Hang on with me. And these are the two there are called input. So we call it input A, input B. So it goes here, and that's the call it the exit, something like that. Output, not exit, output. And here you see that info. So we have 0, 0, 0, 1. That's electronics. So I think that's look a little bit familiar to you. Alright guys, so what does the OR gate say? Output, input, input. It say when the the input are 0, we have a 0 at the output. Alright. When the one of the input is at 1, we have a 1. When the output is at 1, we have a 1 and 1. Alright guys, so that's more or less it. I know it went pretty quick, but I show you an example to explain you a little bit better. Alright, so I made an electronic schematic for you guys. So that represents a switch here, and here we have a diode. So that is an exit, and we go back here, and here we create the generator, the battery. It goes like that, plus, minus. So the current comes here. So this is how we represent the current. It goes here, and if all of them is closed, meaning we have 1 1. If it's a 1 1, all right, let me maybe do it this way. Maybe that would be easier for you guys to understand everything. So here it's at 1 1. It's at 0 0 because it's open. So the current cannot go. If it goes here, it stops here. If it goes here, it stops here. So 0 0. So this LED, that's the output, is at 0. So we found ourselves here, right? So if one of them is at 1, meaning the exit is closed, the input is closed, and so we have a gate here. So that's why we call them gate. So the current can grow through here to here. All right. So it's at 1. So we are 1. So this turns at 1. So it's on. We have light. So let's say we put it back at 0. So it's at 0 like this, and this one goes at 1. All right. So instead of going here, it goes here. It's still at 1. So this is where the OR comes. You can go here or here, and if the two of them are at 1. You can go here and here, no problem with that. But if both of them are at 0, it goes nowhere. 0, it cannot go. The output, I mean the LED is at 0. That's how it goes, guys. All right, so now you have the table here, so you understand how it works. And here you have the schematic. So we have the battery here. So we have the 2 switches here. So because it's the switches are in that configuration. That's how it works. If it was for another door, another gate, I mean, it would be represented in another way. We see for another door, another time. But now let me do the schematic for you guys. Okay. All right. The first thing we need to put together here is this. This is the battery, all right? And we come here. Maybe let me put it like this. Put it maybe this way. All right. And here comes we're going to put the. All right. Let me put all of that together for you guys, so you understand better. Let me get more for you here and here. All right, let's try to make a nice schematic. So if I put this like this, here we go like this. Okay, guys. And I put the other one just like this, guys. Voila. Put it like this. There we go. And you put one of them here. And it goes like this. And now you can put a big one. Maybe that would help. That would be helpful. There you go. Oh, I think it doesn't go. That way it needs to be really long. Okay, so I may need another switch to wire it like this. There you go. We need to do what we have, guys. There we go. A little bit tricky, but we get in there. So guys, the schematic I've done is just this. So instead of putting the battery here, I put the battery here. So if you want, I can we design it for you. In the plus is going to be a minus. It goes like this. And we have the 2 switches like this. It goes like this. Oh guys, I forgot the LED. Okay, we put the LED like this. And we're going back here. At the plus and we have the minus. I forgot the LED. Alright, there you go. I done all of this maybe for nothing, but it happens. Alright. There we go. Okay. I'm trying to find what works best. What works best. Okay. There you go, guys. I finished the schematic. So as I was saying to you, so we have S1 here, that's the switch 1, S2, that's switch 2. Alright. Can open that. Two and 3. So how it works. Okay guys, so let's give it a try now. So I'm going to put the batteries. I push this, it goes on, guys. So this is how it goes. So let me move that. And let's try the schematic, the table here. So we have the table here that says 0, 0. If we have 0, so we don't push nothing. It's at 0, so it's not on. That's the output. Input says if one of them is at 1, let's say I push this one, it's at 1. You see here. If I turn the other one at 1, it stays at 1. At 1, I mean. And when both of them are at 1, so it stays at 1. As simple as that. So that was the OR gate, guys. So that's something pretty used in electronics. I remember back in the day when I was in electronics school, so we use that a lot. We have an OR gate, we have an XOR gate, we have an AND gate, NOR gate, yes gate, no gate, and what's the name of the other one? I think it's no and yes. I think it's yes. You can correct me in the comments if I made a mistake. Yes, and NOR, NAND, XOR, NOR, a couple of the things, guys. So that's pretty used in electronics, pure electronics. Now things are a bit changing, and it's even used in coding for microcontrollers and so on, guys. And real coding too. Okay guys, so I think that's the end for this tutorial today. So leave some like, guys, that helps a lot. Leave some comments if you have any suggestion here, something that needs to be improved. Don't forget to share the video, and see you for another tutorial, guys. Alright, take care.